Another question's come in from Sheriff. What is the design aspects of pre-cooling room blast chilling for orange? Yeah, there's a good question. I mean, the basics of blast chill or blast freeze for that matter. If we talk about a cold room as such, or a blast chill, blast freeze, I'll just show a sort of basic. And again, this depends. Actually, this is quite an interesting question. Are we? Is it orange juice or is it oranges, the fruit? If it was orange juice, then it would go through some form of plate heat exchanger to cool it down. But if we're actually talking oranges, to take the field heat out of an orange, or we're taking them down to a storage temperature. So if we think of a, let's say, blast chilling room, classic sort of way to do it generally, let's do a nice big ceiling mounted evaporator. So we've got our fans, and then we've got our coil block. Generally what you would do is you would store your oranges. If we're talking blast chill, for example, something like this, and you'd have a plenum, which is that part there. Let's make sure the air can get back. And we'd basically blast our air, and this is maybe not to scale, so the air would pass over our product, and then it would come back to our evaporator again. The biggest challenge with any form of blast chill, blast freeze is to actually get the heat exchange from our oranges, so we're actually picking up the heat. If these oranges are stored in a crate, for example, then we need to make sure that the air can actually get through the crate itself. If they're in plastic boxes, that's no good, because the air can't actually access the actual product that we're trying to cool. So we need to make sure that the crates have gaps in them to allow the air to actually get to the product itself. So it doesn't matter whether we're talking oranges, whether we're talking, meat, anything. The main thing is that air that we're blast chilling has to come into contact with the product itself. So hope that sort of answers that question.